Okay, so we've been learning how acids give away H plus and bases, they give away OH minus. Okay, so it makes sense that if you have an acid inside of a solution, inside of water, it's going to raise the concentration of H plus, right? And so you're going to want to write this part down right here underneath the pictures. Okay, but in an acid solution, in an acidic solution, you're going to have more H plus, greater H plus concentration than OH minus. So make sure you write this part down. And then these brackets, if you ever see these brackets, it just means concentration. Okay, so we're talking about things like molarity. Okay, so if I got H plus in there, I'm talking about the molarity of H plus. If we're talking about OH minus in there, it's going to be the molarity of OH minus. That's what those brackets mean. Okay. Okay, so in an acid solution, you're going to have more H plus or a higher H plus concentration than OH minus. Okay, so that's the first thing for today. The next thing you're going to want to write down is this part right here, neutral. Okay, if a solution is neutral, it means that it has the same concentration of H plus and OH minus. And usually neutral stuff is just water. Okay, and then lastly, the opposite of an acid is a base. And in a basic solution, you have more OH minus than you have H plus. Okay, so that's kind of the differences. You have more H plus in an acid. In neutral, you have the same amount. And then in a base, you have more OH minus. All right. No, water is the definition of a neutral solution. Yeah. Good question. Yeah. So we're not going to be talking about neutral too much, at least for now. When we get closer to spring break, we'll be talking about neutral a little bit. But for now, just be very comfortable with the acid and base definitions. Okay, acid has more H plus concentration. Base has more OH minus concentration. Okay. Okay, so we're talking about the pH scale today, and the reason why we need to use pH, so far we've been talking about everything in terms of molarity, right? We're talking about how strong an acid is or how strong a base is. We've been talking about molarity, okay? But unfortunately, in real life, these solutions we're going to be working with, the molarity is going to be very annoying numbers. So for example, let's take a look at the first problem. A venti coffee at Starbucks is 0.71 liters. Okay, that's the size. And inside a venti coffee, there's about 5 times 10 to the negative 6 moles of H plus. And you might be looking at this number and be like, what the heck, right? You might have seen this in your math classes before, but even for those of you that have seen it, it's probably a little bit annoying to look at, right? So the reason why we have to use pH is because most of the molarity of stuff we're going to be looking at in real life and in our labs and stuff, the moles is very low. The number is really small. So I'll show you guys what how to work with these calculations, and then I'll show you guys how to use the pH scale, which is a much easier way to compare these numbers, okay? So before we start, I'm going to teach you guys how to turn this right here into a normal number, okay? So if you ever see this right here, times 10 to the power of whatever, okay, this exponent right here, the small number on the top right, this is going to tell us how to move the decimal point. Okay, so for example, let's write down the number in the front 5. Okay, so make sure you guys write this on your paper. Okay, so the number in the front is 5. So if we have the number 5, where's the decimal point in relation to 5? It's on the left, right, front, back, up, down. Where's the decimal point for 5? Uh-oh. Where's the decimal point for 5? Yeah, on the right, yeah. If you got a regular whole number, the decimal point is always behind it, right? 5 is equal to 5.0, right? And so the decimal point is behind the 5. If you didn't know that, you're welcome. This will help you in your math classes too. Okay, so 5 has a decimal point right here. Now, this exponent right here is going to tell you how to move the decimal, and that's going to give us the normal number that this equates to, okay? So if you ever have a negative exponent, okay, you're going to move the decimal point to the left, Okay, and make sure you guys write this down. If you have a positive exponent, you're going to move the decimal, obviously, to the right. Okay, and the number is going to tell you how many times you move that decimal point. Okay. All right, so if we take a look at 5 times 10 to the negative 6, which direction should we move the decimal point? Yeah, to the left, because it's a negative number. So we're going to move the decimal point 6 times to the left. So 1, 2, 3, 4, 5, 6. Decimal point is going to be right here. So it'll be 0 point, and then you just fill in the places that you moved with zeros. Okay. So all that is to say that 5 times 10 to the negative 6 is equal to 0.0000005. Okay. So just to clarify, the exponent tells you how many times you want to move the decimal point. Since it's negative 6, we move it 6 times to the left. So 1, 2, 3, 4, 5, 6. And then we fill in the empty places with 0. So there should be 1, 2, 3, 4, 5 zeros. Okay. So let me rewrite it a little bit higher so it's easier to see. Okay, but basically all that I just talked about is to tell you that this number right here, 5 times 10 to the negative 6, is equal to 0.12345. Okay.
Is that next to the A part or the B part?
This is all about the A part, yeah. Yeah, I was just rewriting it up here. Okay. All right, does that make sense though? How we can turn this into a number that we can work with a little bit easily on your calculator and stuff? Okay, so if you guys notice, this number is very, very small, right? Okay, and so what we're going to be doing is we're going to be using this number in order to solve the problem. So we're looking for the molarity of H plus. Okay, we've been using the molarity equation for like, I don't know, like 3 months now, since like November. I don't even know what month it is anymore. That's 5 months. Okay, so we've been using molarity equation for a long time. It's moles divided by liters. All we're going to do is we're going to take the moles. So 5 times 10 to the negative 6. So we're going to do 0.123455 moles of H plus. And then we're going to divide it by the volume, which is 0.71 liters. Okay, so today I want to make sure that you guys are comfortable using your calculators. So I want you guys to plug this into your calculator and see what you guys get for your final answer. Now, depending on what type of calculator you're using, you might get different numbers. I'm going to show you guys all the possibilities that your calculator can give you and still be a correct answer. So again, I really want you guys to practice using your calculator for this because this is not going away. We're going to keep using numbers like this. So punch this into your calculator. I'll give you like 2 minutes. Check with the person next to you, see if you get the same answer. And then I'll go over all the different options your calculator could have given you and still be a right answer. All right, so what we're going to do is we're going to take the number on the top. So 0.123455 and then 5 divided by 0.71. And that's going to give us a number like this. Okay, so let me just kind of explain real quick what you guys might have gotten, and then I'll explain how to interpret that number. So you might get something like 7.04, and then you guys see how there's an E minus 6. How many of you guys get an E on your calculator? A couple of you guys. Okay, so let me tell you guys what that E means. Now that E, what we can do is we can rewrite it as 10 to the times 10 to the power of. Okay, so we can replace that E with times 10 to the power of negative 6. It's just easier for your calculator the way they're programmed to put E instead of an exponent. But the E basically stands for this right here, times 10 to the power of. Okay, so just keep that in mind. If you want to write that in your notes, these two numbers are exactly the same. Okay, the front number is the same. E just means times 10 to the power of negative 6. Okay, and then if you guys want to turn it into a decimal, okay, easy thing, same thing as before. Just move it to the decimal point 6 times to the right, or to the left, sorry. And that should give you 0.123455, 0.71. 50704. So all three of these numbers would be valid options. They're all equal to one another. Okay. So if you guys got this, then you're good to go. Now, the most important part going forward is going to be this back part right here. If your exponent is incorrect, that's going to be the make it or break it part of your answer. Okay, so make sure you guys got 10 to the power of -6 or e -6. Okay. If you got -7 or -5, I know it seems close, but those are all factors of 10. That means you missed a 0. And that would be like me owing you $10, but I only give you $1 back. Okay, that's how big that difference is, a 10-fold difference. Okay. All right, any questions on how to punch that into your calculator? Okay, so what this means is coffee contains this many this is the molarity of H plus in coffee. Yeah, did you have a question? All three of them are fine. Yeah, whatever you give me, they're correct. Okay. All right, so this is the molarity of H plus in coffee. And if you guys take a look at the number, it's really, really small, right? So it's kind of annoying to work with. And this is the reason we're going to use the pH scale. The pH scale is going to allow us to talk about things like H plus and acids without working with these really annoying numbers. It's numbers that are a little bit easier to look at. Okay. So the question we're going to be answering in just a sec is we're going to go over pH. And I'm gonna teach you guys how to find out if something is acidic, basic, or neutral. Okay, so you guys don't need to write this part down, but you guys do need to write down this equation. There are 3 equations that are super important today, and this is the first one right here, the one in the box. Okay, so the way that we can calculate or find pH is using this equation right here. pH is negative log, and then the concentration of H plus. Okay, and we'll talk about how to do that in your calculator in just a second, but just make sure you guys have this written down somewhere. Negative log of H plus. That's how you calculate pH. Okay, so just to reiterate, in the pH formula, all we got to do is plug in the molarity of coffee we found earlier. And so on your calculator, depending on what you have, you're going to click log 0.12345 and you should get an answer of 5.15 or negative 5.15. Okay. All right. Now, you guys see how there's a negative sign in the front right here, right? So all you need to do is drop the negative sign. So the pH of coffee, super easy, is going to be 5.15. What's up? Yeah, just drop the negative. And the reason why is because there's a negative sign right here. So negative times negative is a positive. Yeah. Alrighty, guys. Any questions on how to plug that into your calculator? Hopefully not too bad. Again, just make sure you're using one with log on it. Okay, so now that we have the pH of coffee, we can figure out if coffee is an acid, if it's neutral, or if it's a base. So this is the little key that you guys can use, and you might want to jot this down on your notes. You don't have to make a table or anything, but you can just write that acids, anything that has a pH less than 7, okay, the sign means less. So a pH less than 7 means it's an acid. If something is equal to 7, the pH is equal to 7, it's neutral, which means it's basically water. And then if something has a pH that's basic, it's going to be greater than 7. Okay. So make sure you guys jot that down in your notes. That's kind of the key that you guys can use to figure out if something is an acid, a base, or neutral based on the pH. All right, so let's take a look at the pH of coffee. So if we take a look at pH of coffee, it's 5.15, right? Is this number bigger than 7 or smaller than 7? Is 5 bigger or smaller than 7? Smaller. So since it's smaller than 7, coffee is going to be an acid. Okay, so coffee is a type of acid. So next time you're drinking coffee from your parents, just tell them I'm taking acid. And that is scientifically a accurate statement. And you're drinking a type of acid. It's not the acid they're going to be thinking about, but coffee is a type of acid. Okay. Alrighty, guys. Pretty easy. Makes sense how to use pH. Okay, so before we move on, let me show you guys some examples of different compounds that are on the pH scale. So you guys don't need to write this down. This will just be in your notes, and this is already being recorded and whatnot. But 7 right here is going to be the middle of the pH scale. Okay, this right here is the middle. And then as the numbers get smaller, it becomes more and more acidic. Okay, so milk is slightly an acid. You got coffee, which is more acidic. You got some fruit juices, which become increasingly acidic. And then your stomach acid is super duper acidic. Okay, so this is the side that's acid. And if you notice, all the numbers are smaller than 7. Okay, as you go up, if you have bigger numbers for your pH, it's going to become more basic. So things like egg is kind of a base, and then you got baking soda, soap, different cleaning materials. The higher the numbers get on the pH scale, the more basic they get. Okay. All right. So before we move on, let's do one practice problem. I want you guys to try this on your own or with the person next to you, but I want you guys to use this information to figure out the pH of lemon juice, the exact pH of lemon juice. Okay, this is the formula that you're going to be using. Okay, so same one as before. But I want you guys to try this out again, get some practice working with your calculators. But I want you to find the pH of lemon juice today. All right, so all we got to do first is we want to take this number right here and turn it into a number we can punch into our calculator. So 3.8, it's -4, so you're going to move the decimal to the left 4 times. So 1, 2, 3, 4. So you're going to get 0.00038. So this number right here is same as 0.000, so 3 zeros and then 38. Okay. All right, so for your pH, all we're going to do is plug it into this formula, negative log of 0.00038. Okay, so you're going to go to your calculator and do the same thing. So you're going to go log 0.12338. And that's going to give you an answer of 3.42. Okay. And this makes sense because this number is less than 7. Okay. And so it's going to be an acid, which makes sense because lemon juice is a little bit acidic. It tastes sour. You guys are probably familiar with that. Okay. Yeah. That's it. That's how you find pH. Yeah, that's it. That's all you got to do. Are y'all suspicious of me now? Too easy? That's good. Don't worry, I'm going to mix it in with harder stuff later. So don't worry. I respect you too much to keep it this easy. But just for today. All right, let's move on. Now, pH is one way to measure if something is acidic or basic. But there is another metric that we can use. Okay, the other metric is pOH. Okay, now pOH is kind of the opposite scale of pH, and I'll show you guys how to use the formula for pOH. It's very simple. Make sure you guys write this equation down. Okay, if you add pH and pOH, it's always going to equal 14. Okay, so pH and pOH is always going to equal 14. Okay, and so what that means is if you have pH, so earlier we said pH for lemon juice is 3.42. It's super duper easy to find the other one, pOH. All we have to do is do 14 minus pH. And that's going to give us pOH. Okay, so it's an even easier calculation now. Okay, so if you do 14 minus pH, we said pH is going to be 3.42. That means the pOH of lemon juice is 10.58. All right, and that's it. That's how you can find pOH. So lemon juice has a pH of 3.42, and it has a pOH of 10.58. Yeah, what's up? Always 14. That's correct. It's a mathematical thing. That's why it always equals 14. It's kind of the beyond the scope of this class, so it's kind of just trust me. If you want to take AP Chem, I'll explain it in AP Chem in more detail. But yeah, but just trust me for this year. Okay. Real quick before we do the last problem, is that I'm gonna show you guys the pH and pOH scale. Let me zoom out a little. Okay, so I want you guys to take a look at this this chart right here. And let's look at the bottom one first. Okay, the bottom one is the one that we talked about earlier. We said that for pH, if the numbers are less than 7, it's going to be an acid, right? But the opposite is true for pOH. So for pOH, if the numbers are bigger than 7, it's going to be an acid. Okay, it's just the way the scale works. They go in opposites. Okay, so pH less than 7 is an acid, but for pOH, bigger than 7 is an acid. Okay, and then earlier we said that for pH, if it's bigger than 7, it's a base, but it's the opposite for pOH. For pOH, if the number is smaller than 7, it's going to be a base. Okay, so if that's a little confusing for you, just memorize the pH one, and then you can always just find pH. It's super easy. It's just 14. You just use the 14 number, and then you can always figure out if something is acidic or basic. But if you want to skip a step, you can just keep in mind that the scales are opposite. Okay. All right. Anyway, but with that being said, let's go on to the last problem, and then I'll get you guys started on your assignment for today. Okay. And your assignment problems are going to look pretty much exactly like this. Okay. So in the problem, it's asking us to find pH and pOH for this solution right here. Okay. Now, the first thing you want to do is you want to figure out if this solution is an acid or if it's a base. Because depending on which solution it is, you're going to be finding one of them first. Okay. So if you want to jot this down, you can. But if your solution is an acid, you're going to find pH first. Okay, and if your solution is a base, you're going to find pOH first. Okay, so the key thing to do first is you want to figure out if something is an acid or if it's a base, and then based on that, you can figure out which one to find first. And then it's very easy to convert. You just need to use the 14 number. Okay. Okay, so if we take a look at KOH right here, is KOH an acid or is it a base? KOH. Yeah, it's going to be a base. An easy way to think of that is if you look at KOH, it's going to break apart into K plus and OH minus. And we said that OH minus is going to be a base. Any chemical that releases OH minus is a base. So this is going to be a base, which means we want to find pOH first. Okay, so find pOH first because this is a base. All right, so this is the third formula that we're going to be working with today. And it's the same thing as pH. The only difference is it's pOH. And if you notice, all you do is switch the H with OH minus. Okay. All right, so what we're going to do is we're going to take this number right here. This is the molarity of KOH. And so if KOH is that molarity, it's going to also release the same moles of OH minus. Okay, so this number right here is going to be our OH minus concentration. Okay, so I'm going to give you guys about 2 minutes. See if you guys can use this value, plug it into this equation. Again, I want to get you guys some calculator practice, and I want you guys to find the pOH of this solution right here. Okay, and then after that, if you are confident enough to find pH, you can do that too, but at least for the next 2 minutes, see if you guys can find pOH. Okay, take about 2 minutes to do that. So if we take a look at this formula right here, we have OH minus. So all you want to do is on your calculator, plug it into this equation right here. So you're going to click you're going to click log, sorry. And then you're going to be plugging in this number right here. Now, it's pretty hard to punch this into your calculator. So you got to move the decimal 5 times to the left. That'll give you 0.0000. So 4 zeros, 1/8. Okay. So on your calculator, you're gonna do log of point, there we go, 0.123418. You're gonna find your answer, and then you're just gonna drop the negative sign. So the POH of this solution right here is going to be 4.74. Everybody got that? Something close to that? Thank you. Okay, so the POH of this solution is 4.74. Now, what we're going to do now is we're going to find pH, and we can do that by subtracting POH from 14. So 14 minus 4.74 is going to give us our pH. So we're just going to do, my goodness, 14 minus 4.74, and that'll give us 9.26. So the pH is going to be 9.26, and the POH is going to be 4.74. Okay. So pretty easy calculations. If you're comfortable with the log, then this should be a really easy assignment. Whoa. Sorry about that. All right. And then last but not least, let's figure out if this is acidic or basic. Let's look at the pH because I think it's a little easier to work with. Okay, 9.6 is bigger than 7, which means that this solution here is going to be basic. Okay, and the reason why, again, is that pH is 9.26. This is bigger than 7. And you can also do it with POH if you'd like, but the POH is equal to 4.74. And that's going to be less than 7. So it's opposite scales, but they're both going to tell you that it's basic. Okay.